Welcome, welcome, welcome. It's Saturday and we're going to learn how to do some more programming. Anybody who is astute and quick of mind may notice that says Vec2 instead of Vector 2F. That's because this week, how can you put it? My Linux was taken away. So we're on Windows, and these are the files that I have on Windows, and I had to reconstruct what we had already done. Not a problem, well, until you have a look at tests. And yeah, okay, I've got the test. Oh, it's empty. Yeah, it's very empty. I'm sad. All my tests have gone, so we're going to have to make some more. What a shame. Yeah, Vec 3 we're on this week, aren't we? Let's see how we did this. It was Alt, Enter, Create Test. Comes up with a strange thingy. Nothing to show. Okay. JUnit 5. Okay. And I'm going to pull my tests over to the left today. There we go. So we start once more, but this time I'm more prepared, and you should be more prepared as well, because now you know about the problem with floating points. We can do something about that. The problem with a floating point. Let's make a function. I'm not sure whether I should make it here or not. We'll try it. Static. And we're going to call it float equals. Yeah. And we are going to have a float, A, comma, float B. I think that's fair enough. We'll try this out and see what happens. He doesn't like that. Okay, fair enough. Void. No, float. I'm not allowed static. There. Yes, I am. I thought so. Okay. It's actually not a float, it's a bool. There we go, that's better. Return false for a minute, will you? Just to shut up the errors. Thank you. Okay, how are we going to do this? I don't think it should be float either. I think it should be double. Do we use doubles internally and then turn to floats, don't we? Well, it's the results that we're testing, so all our tests are going to be in floats. Okay, I'll go with floats for a minute. If, and I'm going to use math dot, it's going to be ABS. Is that a thing? Yes, it is. Good. A minus B, and we're going to have to come up with something here, is less than or equal to, and we'll call it epsilon because that's its correct name. Is it not already in? Maths? Math dot, is epsilon already in? No. Why not? Okay. There we go, epsilon. We'll need a value for that, won't we? Private static float final. How many things have I put in here? Do I need that one? Oh, right. Okay. Let's do it that way around. And that would be epsilon, and this is the value that we need. And it's going to be equal to... right. 0.0001. As we discussed last week, that is what we're after, and I'm not allowed to do that. Why am I not allowed to do this? Oh, right. Grief. Okay. Right, so if it is less than or equal to epsilon, then return true. Otherwise return false. That's it. That's the whole function. It's as simple as that. So float equals. So when you want to compare two floats, we now have a function that does it for us. I don't like relying on things like unit tests to have something like that in. This should really go in a maths utility. Yeah. Oh well. I'll leave it here for now. I'm not overly bothered about it, but we'll see how that fares, shall we? Right, what is the first thing we're going to do today? We're going to do vector 3, and I'm not going to call it vector 3f. I'm going to call it vec3. Why the change in naming? I changed the names to go in line with a programming language called GLSL, and that is the OpenGL shading language, or shader language, should I say. What that does is it quite handily does our shaders. So I thought it's in the shaders, and we're doing maths. We can call it what we want. I'll call it the same as what they do. It's also the same as the GLM, the graphics, well, the GL maths library, the OpenGL maths library, which is OpenGLM. I don't know about our unit, LWJGL, that thing there. Yeah, still got it in here. Remove POM. What does that mean? I don't know. I'm not sure I really want it in there. I'm not sure at all. I might take that out. But anyway. Here we go. How's our screen looking? I've got a new screen set up, unfortunately. Everything changed this week on Thursday, which threw me slightly. as people yesterday may have found out. We can see chat. Yeah, okay, we can see my notes, yeah. We've got messages, yeah. Interesting messages. Something I need to look at there. I'm just thinking doubles or not to doubles. Yeah, go on then. And then we can do it for all of them. Yeah, I'm happy with that. Just do that. Take that line out. There we go, that's something. Now, what are we doing first? We are creating a new test, which was Alt Insert, wasn't it? Okay, test method. Yes, that's how we did it. So what we're going to start with today is the Vector 3 constructor. Okay. So, how do we want to construct our Vector 3s? We just want to be able to put Vec3 victim, I'll call it, equals a new Vec3, and we'll just give it some values, shall we? 1.0f, comma 2.0f, comma 3.0f, semicolon. Well, we can't run our test because we haven't even got a constructor, I don't think. Okay, cannot be applied. Yeah, expected, actual, nothing, parameters, arguments. Yeah, that's okay. Create a constructor. There we go. Done. There we go. That's now worked. The only thing is, I would like X. Oh. X, if it uses the right keyboard. Y. And Z. There we go. There's our constructor. I think we can get rid of this line now. Okay. I guess we run the tests. And I put my Dubry in here, don't I? And that's in test now. Yeah, run. That one, is it? Let's see what happens. Oh, right, it ran the program. Great. Run test, there we go. Click on this one. There we go. It passes. Fantastic. But what happens if we now test for the next part? Because what we need to test for is... How did it go in here? It's an assert, isn't it? Assert. It was assert. I'm trying to remember what I used. Is it just equals? Yeah, that'll do. Equals. So the expected result is going to be 1.0f, and we are going to get that from victim X. There we go, red. Fantastic. Create field X in Vec3. What happens if I press that? Oh. It does that, does it? Okay. That's not exactly what I want, though. Private. So private float X, so we still can't do that. So we'd have to use probably get X. And that doesn't exist. So let's set this up, shall we? Private float Y. And private float. This is called test-driven development if you haven't already worked it out. And what happens is, by trying to do the test, you're driving yourself to do everything. From class vector 3, do I just do this? Refactor, is it? Generate. Getters and setters. So yeah, I want you. I don't know where it's going to paste them. There we go. Get X is now a thing. Set X, get X, set. Oh god. Yeah. Okay. All right. So we've got some getters and setters. Can I just mark them off? 1, 2, 3, 4. Just a few will do. I didn't make them, so I marked them off like that. And I'm not interested in them at all. I'm only interested in what I'm doing. Why are you learning programming? To help people. Simple as that. People watch. If they want to learn to program, they can follow along and see how it's done. I think that's a nice way of teaching. Teaching by leading from the front. That's how I do it. I'm not a programmer, but do I know all this stuff? Probably. That's a big question for me. Do I know anything? Not really. I'm a research and developer for computers. I do system design. That's what my profession was. I'm now a research and developer. So, yeah, I know a bit about computers, but not all about computers. I do a lot of research. On a Thursday, at the moment, we're doing what my job is, which is the research and development bit. On Mondays, Wednesdays, and Fridays, I'm doing a C++. Let's make a... Well, it's like a programming club where people can get together and swap ideas. But in the meantime, I'm doing an MMO in the background. I'm actually coding up an MMO. It's probably going to be ready for Christmas at this rate. Yeah, that's a bit weird, because I've just had a reshuffle of computers this week, so everything's up in the air at the moment. Okay, this is iClinton97. Oh dear, that's got so many connotations. I was studying software engineering, 2 year completed out of 4 years, but then deferred to pursue my own business. Decided to get back to programming, but instead of going back to uni, deciding to self-learn. Good. I'm glad about that, because I don't think... Let's put it this way. If you go to school to learn about programming, you are going to learn about the past. If you watch this, or hopefully other people are going to start doing this now, you'll see the future. There's a difference. There's a different outlook on learning to program. What I do on a Saturday is the historical one. I will do what you will see in university or school. This is how it's done in school, and how I was taught to program. On Thursdays you'll see me break every single rule in the book, and on Monday, Wednesday and Friday I will break the rules. You'll see the future of programming anyway. Hopefully it's evolving quite nicely already. I think we're up to terrain already. I'll definitely be breaking some rules there. Do I have any resources I recommend? Yes. Cross-platform. All resources you use should be cross-platform. This is Java. I don't normally program in Java at all. It's my most hated language, which is why I'm forcing myself to do it. Yeah. And, well, I've just done that wrong. I'm doing this in Java on purpose, one, because I hate the language, and secondly, because it's the best teaching language there is. Yeah, there's a lot of Java programming out there, but you might find Node.js would get you further, PHP, if you're looking at the Java scene, because you're looking at web applications all the way there. Visit me on a Thursday afternoon at 2 PM if you can, or watch that stream. I'm just trying to think where that stream is. It's not on this computer, it's on this computer. Come on, Blades. Get your act together. Here we go. It's on here. I've only just started it as a possible. I mean, if people watch it, then I'll do it. It's called Blades World. I've got... I think we're live. Yeah, we have. We've got a video in it. So I think that's it, really, at the moment. Is this number 1? Yeah. So this is my, like, test one to see if people want to see it. It's got a view already, so I'll probably do a second one. But that's on my YouTube channel at Amberskies, if you want to look that up. Things like NPM, Node.js, I think that's what I'll be doing on next Thursday. I might even be doing some programming in it. I think I am. I'm going to be testing something called Electron, which puts a browser into a window. Because I don't believe in them. The question is, iClinton97, fantastic question actually. How come you do so many different languages? I don't. I don't do any languages. I program. There's two ways of looking at this. You either decide you're a programmer, or you decide you program a language. Which one do you want to be? Anybody can learn to program a language. A programmer is somebody who understands the computer. Yeah. Well, if you want to become a programmer, then the language you want to start with is called assembler. And you want to learn how a computer works at the base core, down to the CPU, how the CPU works. With that knowledge, and then you build up into something like C, then onto C++, then you're into Java, C#, F#, Python. Node.js, and all spin-offs start going off there. I'm thinking of doing one in Rust as well. I've been thinking about this for a long time because I like the idea of Rust, but I'm not sure they're ready yet for programming. I mean, people are programming in it already, but are they ready? That'll run me test, won't it? Oh dear. Assert failed. So my test has failed. Hey there, Linksy Cat. Yeah, first you should learn how the circuits work if you're going down to assembly. Yeah, and, nor, not, and NAND. NAND is the main one. That's most chip technology. I was doing, what was it? The qubits on Thursday night. Qubits, my God. That was an eye-opener. Because I'd never seen them before. Here we go, we've got a thingy here. What does this mean? Debug. Oh. Right, it'll allow... I've never seen this before. What happens if... Oh, right, it goes red. This... Oh, right, it puts these up. No fields to display. Victim, XYZ. Oh, lovely. Step over. I'm liking this. Where's me step over? No, it's return. Step into. No, step over. Alright, okay. Whatever. Don't know what that's about. Fantastic information you can get on this IntelliJ stuff. Oh, you beaut. You absolute beaut. What a fantastic teaching language this is. Can we stop now? That's the debugger. Go away. I'm looking at the top now. Tests failed 1. Reflections. Oh, reflectivity. Oh, that's nice. So this isn't going to work. Why is it not going to work? Well, expected 1, it got nothing. What I should have really put here is my new thingy, float equals. But that put true there, so you can't know. Okay. That would be Boolean. Alright, so let's do this the other way. Let's assert true. And instead of that, what we do is we put that into our float equals. Float equals, open. And it's 1.0, isn't it? 1.0f, comma, space, victim get x, assert true. Now this should also fail. And we're getting some messages in from Linksy Cat. Yeah, electromagnetic physics. Yeah, that's what I was doing Thursday night. Don't go there. Atomic computing. Yeah. Or whatever they call it. Oh, right. I need another thingy. Yes, I do need another thingy. Thank you for that. Thank you, Java. Alrighty, let's try that again, that test. There we go, still fails. True, but was false. So there's the assertion. So now we've got this new float equally thingy. That's quite useful. So we've got our epsilon, we've got our accuracy. That gets around all the problems with floating point errors and means that we can go to 4 decimal places quite happily now with our tests. Okay, let's continue our tests. So we have assert true. and it's float equals, and it's going to be, why did I put space there? No, I didn't. Right, okay, 2.0f, and that's going to be victim dot get y. Okay. Does it still mess up? Oh, right, I've done it bad. That looks right. Okay. Let's get all our asserts in. So this is how it starts with programming any class, in my view. Linkscat, when you're using ASM, you might have to deal with complicated I/O registers on some devices, especially if you're using ARM. Oh god, yes. Yes, indeed. There is a lot to learn in ASM. A lot to learn. I pressed the wrong button there somewhere. Thank you. Tab. Alrighty. So we want now, is it 3? 3.0f, comma, victim dot get z. Now all of these, oh god, brackets. I'm going to get doomed by brackets today, and I can tell it. Alright. So I've put an extra space in that one by accident. Okay, and we've got an extra bracket on this one by accident. Okay. Right, that's all correct. So this is how you would test a constructor. You would set or create a constructed victim. In this case, I've called it victim. And then you would test that each of the given values were true. And of course, getters and setters come free here. You create those, or the computer can create those for you in Java. I don't use them at all, usually. It's just I'm doing it this way for teaching purposes. And yeah, it'll just say, I'm sorry, but no, this just doesn't work at all. So let's run. There we go. Everything's just not going to work. Our constructor is just not going to work. Okay, even though all the programming parts are in. So now we need to know what's missing, and this is where the programming comes in. What we haven't done is we haven't set our variables here. Now, I'm just thinking, if I put, does it tell me? Access can be packaged private. It doesn't tell me. That's interesting. If this was C++, I'd get a squiggly line saying you haven't set your variables. But here we seem to be happy. Happy, happy, joy, joy. That's a bit bad. I don't like that. So in Java, be careful. In C++, you'll get warnings. And in C, you wouldn't have this problem. And in ASM, we certainly wouldn't have this problem. So what do we have to do? We have to set this dot x equal to x. Okay. This dot y, you can see the colour change on the x, y and z. Look at the colours if you can. I know that some people can't, but I'm sorry for that. But the colours on this editor change. And that's the program. So all we're doing is we're taking that x value there and x equals x. So purple equals white, purple equals white. So all we're doing is setting this x to that x, y to y, z to z. Now if we run our tests, there we go. Okay, our constructor is good. It works now. So all of this is now true. And that's what we needed to know. if we put values in, we know that our function will store those values and we will be able to use them. That's what a constructor is for. A constructor constructs the object in this case being victim, which is a vector 3. And I bet Linksy Cat's going to say something about me using that vec3 now. Oh, you've gone to GLSL? Yeah. I know. Okay, what we're going to do now. Let's do another test. Why not? So, test method, void name, vec3, underscore, who should we do? Length. No, vector length. I want it more explicit here. Yeah. I'm happy with that. So, what we do over here... Oh no. It did me a constructor. I wonder if it'll actually construct this. No, it wouldn't. I'd have to have that as length. Never mind, I'll do it myself. So on the right hand side, what we do is we decide to put public so that people can use it. And it's a float, return value, so whatever length this becomes, and I'll show you what this means now. And that's all we're going to have for that. Return 0.0f. Okay. We have to have a return value. Alright. I'm going to have to keep closing that off now because we're getting smaller. Here we go. So I've outlined the function that we want. And the function that we want calculates the length of the vector. And to calculate the length of a vector is... Oh, I'm on Windows, aren't I? Oh, yay! Come here, you babe. Epic time. What colour shall we have? Yellow's good enough, isn't it? It's on a grey background, isn't it? Can we see that? I'll go with orange. Is my pen not working? Oh, I put it on the wrong one, that's why. Here we go. How good is that? Yeah, that's good enough. Okay. So what a vector is in 3 dimensions is an X, a Y, and a Z coming straight out of the screen at you. So positive Z is pointing at your forehead here. What this length does is take those numbers and find the dotted line for the final position that it represents, X, Y, Z. And it will give you the length of the dotted line. So I hope that makes sense. Yeah? No? Yeah, that's, I mean, I usually use it that way. So that's your X, Y. Your Z you can't see. You have a dotted line coming out to a point somewhere in 3 dimensions. That's 0. And that's X, comma, Y, comma, Z. And really it's just Pythagoras. So what we're going to use is something like Pythagoras triangle to work out the distances. So using these distances here. So that's going to be interesting if I can do that. Okay, Let's get rid of that for a minute and go back to our pointer. Come here. All right. I'll pop that off screen. I don't want to keep it on screen. There we go. So how do we test that? We need to know a length. We need to be able to calculate this ourselves. So we need a length that's easy to do. What we do is that. So vector 3 length. Let's see what it comes up with. Yeah, okay. Do they call it magnitude? What is the length of a vector? Here we go. It does the 2D one, of course. No, I just want the numbers. See, it's in GLSL as a length as well. So that's good to know. Oh, they can draw better than me. Hate them. No, it's not going to give me the numbers, is it? Oh dear, no, I don't want the formula. I know the formula. Not very helpful. There's the formula there. That's the formula. Actually, yeah, we can take that, can't we? So, let's just copy it for a second, will you? Yeah, bad news, Linksy Cat. I lost my Linux. Not to worry. I'm solving those problems. Just get rid of that for a minute. So that's the formula. So what we will have to do is, first of all, we'll need a victim. And then we'll need to work out a float. Alright. Here we go. Let's get ourselves a victim. Victim equals a new. And we don't want difficult numbers either. Vex3. I'm just thinking, it's the square root of that lot. SQRT. So that's okay. And what number shall we choose? 1, of course. That's always a good number. We'll have -1, because that's also a good number. I can do that one. And 2.0f. Okay, we'll have those numbers because those are easy. So I've got 1 times 1 times 4. 2. 2 2s are 4. 4 square root of. So that's the square root of 4. So all we have to do. Why is that? Oh. You have to put your F's on. I forgot about that. So all we have to do now is assert true that float equals, and the first number will be the math dot square root SQ SQRT of 4 comma it's a float though. No, it's a double. Okay, that's fine. We're allowed a double. And whatever victim.length is. So it's victim dot length. Did I not do something right? I thought that's how it was supposed to be done. Are we not allowed to use functions within here? Alright, that's okay, that's okay. Right, so I'm not allowed to do that. So I have actually got a double expected equals the value of math dot, why won't it come up? Square root of 4.0 f then. Why am I not allowed to do that? Oh, it's a capital M. God, I'm an idiot. We're in a different language. Come on, Blades, get with it. There we go. Sorry about that. There we go. So that's the assert that we want to do. We want to make sure float equals is true when math, the square root of 4 is the length of our victim. So it's 1 times 1 is 1. Is it plus? It is, isn't it? Plus 1 times 1 is 1, that's 2. 2 times 2 is 4, so it's 6, not 4. Is that true? Yes, it is. It's Pythagoras. Well, we're going to find out, aren't we? I think that's correct. Does anybody else think differently? Please type in chat now if you think I'm wrong with 6. We have to put it through float equals because I know there's going to be a floating point error on it. That coffee whistle. Okay, let's do our tests. I can test it singular, can't I? I can just run it back from here. Yeah. So let's try and get a false, because we haven't written it. The whole point is get a false first. Get an error first. Otherwise, how will you know you've written it properly? You can't have a positive without a negative. That's what I'm trying to say. Always write your test first. And as you can see, it looks nothing like what I'm about to put in here. Because what I'm about to put in here is ridiculous. I am going to put in, I want a float as the answer. So I'm going to have one of them. We're going to have a math dot sqrt, and then we are going to do that, and we are going to take x times x plus, it won't work, will it? Damn it. Never mind. Y times y plus z times z. And that's it. that's the whole thing. That's the, do we put it on one line or not? May as well actually, it's of no value like that. Yeah, it fits on one line. There we go. So that's what I would return. Does that look right? Well, let's find out, let's ask. Yeah, vector 3, or vector length, passed. So that we now know that that is the correct version, which is what I actually wrote down here underneath to remind me. Okay, new test. Alright, what should we call this one? Vec3. Vec3 underscore. What should we do next? Dot product? Yeah, okay. Dot product. That's how I look at it. Is it all one word, dot product, or is it two? Don't know. Never thought about it. Until now, because I've just typed it. On the right hand side, we can fill that in. Can we get rid of these getters and setters somewhere? It's going to be, again, a public float. It returns a float. So public float. Dot product is a floating point number. We'll just call it dot. And it's going to have a vector 3. Right. Now, what do I mean by that? What do I mean by right? There's a left and there's a right, obviously. Left is, let's, x, anything in maths, x plus 1, no, let x equals x plus 1. That's the simplest thing I can think of right now. The left-hand side, get off, is here, and the right-hand side is here. Okay? So, let me, can I enlarge that? What size are we on? How big is this on your screen? No, I'm not going to mess around with that. This is teaching, it's not about the code. So let's do it. Okay. This pad needs to be closer to me. God, this desk is not really set up yet. It's all new to me. So you have the left, which goes on the left of the equal sign. You have the right, which goes on the right of this equal sign. So on any equation, there are two sides to an equation. There's left and right. So the right of the equation is what you're dotting with. So x dot y is what we're looking at. And of course, in this case, it's vec3x and vec3y. So that's what we're looking for, that kind of thing. That's how I want to program it. And with that in mind, let's do it. Better get rid of this lot here. Oh, fantastic. Puts the keyboard up. Well done. Who asked for that, Windows? I didn't. So that's what the left and the right means. And it's done it again. Thank you. What or how are we going to do this? First of all, we're going to need two vectors this time. We're going to need two vectors. So we'll have a vector vec3 left equals a new vec3. I don't know what values I'm going to give it yet. I'll think on that. Vec3 right, equals a new vec3. Don't know what values I'm going to give it. God, let's have a look at the equation. We'll have to look at the equation in a second. And what we are going to have to do is, you should have your assert true separate. Yeah, that's right. So what you would do is you'd have assert true, float equals, and then it would be whatever we think, 0.0f at the moment, 0.0f. Well, no, this is going to be left, so it's going to be left dot right. So that's the equation. That'll give me my floating point on that side. Lovely. Are we happy with that? Yes, we are, but we need some values. Alright, let's have a look at what the equation is for a dot product. It is the... I'll write it out actually. It is left dot x times right dot x. Okay. How shall we do this? I think we'll just use x. Can't. Yes, we can. Right, so that at the moment is illegal. Okay, I know how to do this now, so I don't need that. Good. Right, now I know what it is. It's x times x, y times y, and z times z. And are we going to add them together on a dot? Yes, we are. All added together. So let's put 2.0f, comma 3.0f, comma 4.0f, 5.0f, comma 6.0f, comma 7.0f. This is going to be fun, isn't it? So let's see what we've got. Where's my pen? Alright, let's see. We've got 2 times 5 is 10. And it's plus, isn't it, for dot? Yeah. 3 6s are 18. 4 7s are 28. That's the answer, which is 6, 2, 3, 4, 5. So that's what our answer is there, 56. Well, let's see if I'm right. Anybody disagree? I never know. So let's put 56 in here and hope I'm right. Okay. We'll just take you out of view. No. I'll leave it on, I don't care. So I'm expecting 56 to equal left dot right. And I have accidentally gone over that slightly, so yeah. I'll just take that so you can see it. Left dot right. Is that going to work? Well, let's find out. We've got a little green thing here. Let's test it. Run. dot product. Remember, we want the failure, so we've got our failure. It doesn't work. We never programmed it. Okay. So what should I return to make it work? So to make it work, what should I put here? We are just going to return x times right dot getX plus y times right dot get y plus z times right dot get z. The other thing about programming, you asked earlier about why I just program in any language I feel like at any time, is because most of the time I create my own language at the beginning. Like this is just like creating my own language here. And I stick to certain rules and it makes the language very easy to use. I'm not exactly an expert or anything. So it gets me by. Will that work? Let's find out. Will it work? Yay! We got it right. Fantastic. Let's bin that then. Thank you. We've got dot product now. That's fantastic. Who said writing maths libraries was hard? I never did. What should we do next? Alt insert test method vec3. Let's make a new. Let's do a new one. What we'll do next is the cross, and that's a product as well. Product. I actually enjoy coding this way. It's really strange. I haven't coded this way in years, and last week when I tried it, I really enjoyed it. I'm thinking of coding in, just stopping messing around and doing everything with tests. That'd be interesting, wouldn't it? I'd write some very good files then. Not the rubbish that I'm writing at the moment. Which is half on guesswork, half out on a limb, on the edge. Never knowing whether it's going to quite work or not. Which I don't mind, I mean, that's okay, but it's research and development, that's what I'm paid to do. I mean, I'm not paid to test. that's what they do, not me. Alright, so let's outline ourselves a cross product over here. Public float, is it, for cross product? No, it isn't. A cross product will give a vec3. So it's going to be a public vec3. And we'll just call it cross. And we'll need a vec3 right. Because we have to, it's one vector crossed with another will produce another one. There you go. Would you like me to explain the mathematicals behind this? Nah. I'm just thought about it and it's nah. Cross products. Let's see if they've got a better way of saying it than me. Here we go. Vector cross product. Let's see if I've got this right. Cross product Wikipedia. Here we go. This is getting complicated. Sorry. Is a binary operation on two vectors. Yeah. Independent, yeah, A and B. Oh, wait a minute. Yeah. Cross product AXB is a vector that is perpendicular to both. So if you use a two-dimensional cross product, you get the perpendicular to both. To give you an example, I can do a 2D one. I can't do a 3D one because it'll just take too much drawing. I'll do it in 2D. So I think I can draw this in 2D. Let's try. So take two vectors. We'll have vector 1 here along the y-axis, and we'll have the second one perpendicular along the x-axis. Both of these are vectors. They have length, magnitude and direction. So there is an xy, that's going to be, let's call it 0, 1, 0, and that one's going to be 1, 0, 0. I said I was going to do it in 2 dimensions. Come on, blades. There we go, in 2 dimensions. Alright, that's the vectors. What is the cross product? Well, the cross product of those two happens to be the z direction. I guess. It would be, wouldn't it? It'd be coming out of the screen at you. So it'd be 0. That's the cross product, there isn't one. How the hell am I going to do this? I think you'd find that's a cross product there. This is holding that 3 dimensions in my head is not going to do me any good. It's hard to explain. Is the best way of putting it. And I'm not a maths teacher. Oh God, far from it. So I'll put down the equation. The equation is going to be awkward. I'm going to have to write it out in full. I am going to have to write it out in full. Oh God. Let's see if I can. It's y times, we'll call it O, other z. Oh, we're using left and right, aren't we? So right z minus z times ry. Is that right? Yeah. Next line is z. The first one was y, so it's z rx minus, you go on to x then, yeah, y, z, z, x, yeah. And that's times r z again, yeah, go back to the first, yes, that's right. Okay, and the last value or float will be this is an awkward one. What haven't we used? X. How do you remember these things? You don't. Yes, you do. Y minus this line is always easiest because it's the ones that you haven't used. That's Rx, isn't it? There we go. So that's what we are testing. So we are going to have left and right again. Yes, because you left, cross, right. Yes. Okay. So let's go with it. Vec. Cross. Left. Let's get this right. Left. Vec 3. This is going to be fun to work out, isn't it? Left equal. I know. I'll just choose the values that are above. This is going to be a difficult one. Because what we have to do now is exactly the same. Assert. Assert true. That float equals, and it's just going to be, I don't know the number yet, and it's going to be left dot cross open brackets right. Does that give a value? No, it doesn't. My bad. Alright, well, I'll do it. Alright. I've done it wrong. I want to compare it to that, don't I? Yeah, so this assert is wrong. Dot X. This is looking awful. We're going to have a result. Okay. I'll just put 0.0f in there for now. And we're going to need 3 of them. X, Y, and Z. We are going to need to do a result. So vec 3 result equals new vec 3, and we're going to have to work them out. So let's see if we can work these out. This is going to be fun, isn't it? Okay. Okay, let's try working these out. We need an X, Y, and Z value for cross product. Alright, I've got the equation. Let's have a look what we can do. So X. Let's put the values in. So that's 2 times 5. So that's 10 minus Z4 times 6. Which is 24. Is that correct? So, no. It isn't already. RZ 7. All the numbers should be different. So that's 14 off 24 minus 10. Okay. Am I right now? 14 minus 24, yeah. So the first, that's x. So that one there is minus 10. I don't think I'm going to need this result after all. So we'll have u. Next one in. Z is 7 times x. No, z is 4. I'm not doing very well at this today. That's 4. 5. X is 2. RZ is 7. 4 5s are 20. Minus 14 is 6. X 2. Y 6. Y 3. X 5. 2 6s are 12. Minus that is 3 15. Minus 3. So those are the numbers I'm expecting. Okay, let's have a pointer then. So it's minus 10, 6, minus 3. So those are the three numbers. And we have to get, oh yes, we are going to have to get those from, right, result equals left dot cross right semicolon. So that should be result dot get x and just swap that in for the numbers. X, Y, and Z. Okay, so that's the test. Are we alright with that? I mean, ask away in chat. I mean, chat's available to everybody here who's watching live. Obviously, if you're on YouTube watching this later, well, ask questions in the chat below as well. I mean, I'm not too fussy. I will try and answer things, but when it gets deep and mathematical, it becomes difficult to explain in human terms. Alright, shall we test it? Make sure the right will compile. Make sure we compile. Okay, we're doing complex stuff. We should get a false. Oh. What? Oh, that's the dot. Can I have the cross? Yay! False. That's what we wanted. So what should I write in here? Yeah, right, okay. We need to write that equation in here, don't we? So let's split it down and make it easy on ourselves. Let's take each one. So what I'll do is float. And I'll call it x underscore for just local. That's standard notation for local. I don't know if anybody uses it or not. That's what it was. Some people use L underscore X as well for local X, but that's up to you. I don't mind which one you do. So it's Y. Let's just rub this out now. Can we just rub these out? Thanks. Just clear up the space a bit. Okay. So it equals a Y times, and it's right, isn't it? We've called it RIGHT. Dot get Z minus Z times right Y. Is that correct? YZ, ZY. Yep, that's right. Next one we'll do is float Y underscore equals, and that's just going to be a Z times a right, and this is dot get X minus X times right. It's actually not too bad an equation. He says. How the hell did I just come out with that so calmly? You have to be nuts to do equations like this. Nuts. Compared to what we're going to be doing, this is child's play. Well, don't worry, I've got to do it, you don't. You can just copy down the code and know it's right, because you've seen me tests and you know damn well it's right. So this one is X. This is Y, isn't it? Yeah, right, Y. And that is Y times right dot get X, isn't it? Yeah. Ding. Then all we do here is replace our numbers with X underscore Y underscore and Z underscore. Is that correct? Yes, I think it is. And drum roll. It's getting to the stage where we need a drum roll on these tests. Have I got it right? Drum roll. No, we haven't. So, which one failed? Dun, 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 dun. Does it say? Session failed, true, false, right, okay. He's going to give it me or not? No, it isn't. Okay. One test at a time. Test cross product. Right. So it should be true, and it's false. And it's quite true, so it's, let's have a look at the equation again. Y times get Z, yeah. So it's Y is 3 times 7, 21, minus 4 times 6, 24, that's minus 3. So it was a bit large. Are we correct? Yes, we are. Thank you. Let's see if I got the next line right. Come on, give me a 1 right. Oh, I did. I got that one right. Yay! Blades did something right. My God. Are we okay now? Cross product? Yay! All true. We're passing all. Double check at this point. Go right to the top of your tests and do the full lot. Run vec3 tests. Okay, make sure everything passes. You can see it's starting to come up now as a line. In fact, I might keep that as the run. Do the whole line, because it's not taking long at this point. It says doing single ones. Why have I got a stopper there? Go away. Yeah, that's working. That's fantastic. The equation helped me as well. There we go. Thank you, equation. Whoever gave me that. I think it was Khan Academy. Again, if you want to learn more about this from real teachers, especially for vectors and matrices, which we're doing next, Khan. How do you spell academy? It isn't, is it? Try that. Yeah. Free online courses, lessons and practice stuff. This is possibly what I would say is a good place. So learners start here. And there you go. You can learn anything you want. Khan Academy. That's a shout out to them for being so damn good to me when I needed stuff. Okay. Have we run out of tests? Cross product we're on, are we? Oh, that's not bad. Control. Insert. No, that didn't work. Control. Insert. Something's not right here. Never mind. I'll do it manually. So it's at test void vec3 what we're going to do now, vec3 normalized. I'll need one of them. It doesn't take anything. There we go. Good. Let's put a test up. That's good news. Alright, let's get our framework set up here. It's going to be public vec3. Yeah, cheers, Linksy Cat. He got me on my spelling, that's good. I'm glad somebody knows. He's probably watching enough of my videos now to know that I'm useless at spelling. Normalized is public. Vec3. Normalized. There we go. And it spurts out a vec3, does it? Return. a new vec3. There we go, that should do it. That's a blank, normalized. We only need one for this, so we'll have a victim. And I need one that I can do. Yeah, I've already thought of one, victim. I'm terrible, aren't I? Yes, I think I can do this. Vec3 victim equals a new vec3. Linksagat, trying to decide on what software I should use for UI design. So far I found Lunacy? And Vitra, which seem to be free and work on Windows. Have you tried Qt? That's what I use. If I'm doing UI, what's the other one? I'm GUI. IMGUI. I think it is. QTC++. That has a UI system within it. Also the Windows UI systems. There are some in Visual Studio. Problem is obviously licensing. What we're going to put in here, don't know. Not F. The one I've used in the past is I'm GUI, but I think that's in C. Most of them are anyway. Let's just put that for a second. That's our victim. What we're trying to do is one of these here. Is it? Yeah, it is. I think we might be doing something like this. For this one. Now let's see what we can do. On the left we're going to have a number, which is the normalized vector of something or other, which I'm about to choose any second now. I need to know the length. Square root of 6. Okay. So those are going to be my dooberries, my test thingies. By the way, what I am doing are only simple base tests. These are by no means what you would do in a production environment. You would use these to start off with, yes, but you would go further and you would try and break your code. Yeah, before somebody else does. Like me. Alright, so we know that that is true for that statement there, and that's the length. So I'll copy the length. So for normalized, it is x. So that is 1. 0.0f divided by whatever I've got on my V. This is, we'll do that 3 times. Copy. Paste. Paste. That's a -1, and that's a 2. Okay, square root of 6. Yep, that's okay. You'll have to come down now. And what we are yes. We are going to do it to itself, aren't we? So it's victim normalized get X. That probably won't work. Let's try it. So victim dot normalized dot get X. Is that correct? It's not complaining at me. Normally this thing complains like heck at me. Interesting. Maybe I'm getting the programming done properly for once. Now that should give me a negative. There we go. Normalized. Comes up with a cross. It's failed. One test failed. There we go. Fantastic. I like them when they fail because it means that I can now write this part here. And it's just going to be an easy one, I think. We are going to have float length equals LENGHT. That. I know. It's sad, isn't it? And then it's X over length Y over length. Okay, it still seems to be giving me those things. Okay, and Z over length. No, not double. No capitals, please. We're British. That should do it, I think. Let's run our test and see whether that line there turns to a green tick. Yes, we got it right. Fantastic. That means we got the function right. If you're wondering why I'm going to all of this effort for maths, for a maths library, especially on a 3D engine, because it's a 3D game engine that I'm going to design, it's because there's no other way of testing it. If you get it wrong, it becomes a nightmare to debug a 3D game engine. So if you get the maths wrong, you are goosed. Right, we've done normalized. Are we going to do rotate? Yep, we are. Steve 7411, shout out to you, mate. Any particular reason you're rolling your own math library? Yeah, everybody should. At least once in their life, do their own math library. Because you'll find out things like this, epsilon, here. And that this library is only going to be reliable up to 1, 2, 3, 4 decimal places. In fact, I should be putting it up here. And it's space library can only be tested to 4 decimal places. Thank you for reminding me. Due to floating point maths errors. Alright, that'll do. Should really put that in. It's things like that you learn, and that's what we learnt last week when we were doing some testing. That I was doing assert true, and it was all coming back false due to the floating point. Have you considered making the vector and matrix classes generic? These are generic, I would say. I only write the maths library once, and then I use the same maths library over and over and over again. I have written 2 maths libraries in my lifetime already. This is the 3rd time I've ever done one. So there's different things going in this one. I'm doing things differently on this one. So at the end of this, I will be comparing it to my other ones, and I will be keeping the functions for the future that I like, and I'll be discarding the ones I don't like. So it's a learning curve. I'm doing this as a learning series on Saturdays. So I thought, well, instead of using somebody else's maths library, we'll do our own, and I'll show people how to do it properly. Because this is the only way you can do a maths library properly. This is what I'm doing. So that's the reason why I'm here, doing tests and hoping that Java spits out the right numbers and that my maths is right. Alt insert test method. What we got next? Oh god, we are going to do it, aren't we? After normalized comes Vec 3. Yeah, I lost all my Vec 2 tests from last week. I'm damned annoyed about it, but all I'll do is copy these tests over and redo them. So I'll be fine. I'll do that after. Let's have a look, rotate. Oh, I'll show you how. You'll laugh your head off. Somebody in their wildest dreams decided to click on something on Windows like this, see that there was an unused portion on here on my D, which was my Linux over here, and reformat it into D as they thought it was blank. Thank you, that person. They lost everything that was on that drive, which is lucky because I own a server, so I don't care. This is the same program that we had last week. It's just got Vec 2s and Vec 3s instead of Vector 2F and Vector 3F. Just worded slightly different. So I had to remove some stuff that I had on Windows. And yeah, it's okay. So if you're wondering where my Linux is now, it's here in something called Manjaro Arch. I've put it to one side in a virtual box. So I'm not having to do that again. I never fall for the same trick twice. Oh dear. Oh, I think we're doing me a favour. We're just cleaning my computer. Which is fine. You can never ever delete all of my stuff. Ever. It's all stored. Vec 3 rotate. I'm sitting there looking at it thinking. Let's not think about it for a second. We got our normalised done, didn't we? I think rotate's going to be the last one because it's Blaming difficult. Public. Vec3. Actually, we're only on 1 hour 48. I'm going through this at quite speed whilst chatting to you lot. Wow, that's unusual for me. Blades is getting faster at this. What are we going to do? You got to slow me down, you know, and ask me questions. I mean, interaction while learning is the best idea. It's like, why am I using public Vec3 rotate? Why am I not doing this in a different way? I don't know. It's just, this is a way that I'm just going to try it out and see if it works. And that's the truth. So to rotate in 3 dimensions, we need 2 things. We need a Vec3 axis and a float. Here it comes. Angle what? Oh no, which one's it gonna be? That's degrees. I don't like forcing people to use radians just because I do. I don't think that's fair. So it's degrees. I think it's only fair that I do it in degrees. Yeah, I know. The maths library in here uses radians. So I'll use degrees to show you how to do it. How about that? Right, on a Vec3 rotation. How am I going to test this one? Without actually writing the code, how am I going to test it? This is going to take some ingenuity. We are going to need a victim, an axis, and an angle. Wow. This is going to be hard. No, it's not. We can semi-cheat, I hope. Right, let's start with the victim. The thing that we're going to operate on. Yeah, I always call them victims because I'm operating on them. And we are going to make that a new Vec3. And I am going to slightly cheat a little bit. X 1. Y 0.0f. 0.0f. I'm going to start with that one first and see how far I get. Alright, I want to hopefully make this go counterclockwise. If this doesn't go counterclockwise, I'm in trouble. Let's see if we can. Now, rotation in 3D and 3D game engines should go counterclockwise as a positive. As OpenGL, which is what we shall be using, is a counterclockwise or left-handed system. Or right-handed system. 1 second. Yeah, it's a right-handed system, sorry. So it's counterclockwise. Which is why when you're doing your drawing of a triangle, you want to go counterclockwise around the triangle when specifying each point. So you have 3 vertices specified counterclockwise around the triangle. So we need to get our rotations to do or to stay within OpenGL. So we're going to have to go counterclockwise. I could actually put it on here, CCW. because it's only on the test then. Yeah, I will. And you'll find that in OpenGL. You can specify to OpenGL which way round its rotations will go, whether it'll react clockwise or counterclockwise, but by default it's counterclockwise. There we go. What do we do to our victim? We do to our victim the following. Victim dot rotate axis. Let's pick an axis. That's I'm thinking 90 degrees, yeah. Good spot there, Steve. What's 90 degrees in radians? Pi over 2. Or pi over 4. It's pi over 2. Okay. Rotate vec3. I just went down the x-axis, didn't I? Let's rotate it around the z-axis. So the axis, the positive z-axis. Yes, that'll work. Got it. 0.0 f, comma, 0.0 f, comma. Right, so I'm going to use the positive z-axis, which is coming out of the screen. So stick your thumb towards your forehead, and then curl your fingers on your hand, and that's the way we're going to rotate. That's why it's right-handed, so it's counterclockwise. And you can see that perfectly why it's called right-handed. Comma. Angle in degrees. Oh yeah, I've got to do the angle in degrees, haven't we? So 90. Yeah, you're right. Darn it. Why is my vec3 not working? What did I do wrong? It's Java. I can't do it that way, I know. Just realised. There we go, that reads better as well. Alright, so let's go back up to an easy one. That one there. It's the same as certs. And it should come out pointing in the Y direction by 90 degrees. So it'd be 0, 1, straight up, 0. So the vector should go from pointing straight to the right to pointing straight upwards if it goes by 90 degrees. Good. How do we make it do that? Oh, sorry. There's no return on this, is there? vec3, damn it. Yeah. You can see the problem with putting 0.0f in all the time, that sometimes you might test for this by accident, or your tests may pull up zeros. Because you're trying to structure it in such an easy way that you can do the calculations. So you do have to be careful when you're just putting the faults, well, just padding, you know, stubbing this out, it's called. Let's run the tests. We should get a negative. Java cannot find symbol. Oh dear, what did I do wrong? Okay. My bad. Now I have to run all tests again. There we go. And rotate counterclockwise has failed. Good. Thank God for that. Why have I still got a red mark there? Oh right, it's... Actually, I didn't know it did that. There you go. So it's here. Lovely. Now we have to get it to go true. Help. Let's see if we can do this, shall we? Okay. Double. Doubles. I'm going double. Double. We'll call it rad. Equals. Math to radians. Angle degrees. There you go, that's your first line. Next line is double. I want the sine of the angle. Sine equals got to get it the right way round. Right. Do we have to switch this around to a minus? Let's find out. That's what the tests are for. Math dot sine, and it will be minus rad. I don't agree with that. Is it rad or minus rad? For counterclockwise, I think it's minus. We'll need the cosine as well, so we'll have that. Math.cos, and we can take rad, minus rad again. Makes sense in my head, but it's not normal for me to do it this way. Now we go absolutely loopy. I totally agree, Steve. 7.4.11. To make the test pass, all you need to do is return an up unit vector. Absolutely. But I'm just doing these as example tests. This is not how you would do it in a production environment. In a production environment, you're quite right. The first response would be to return a unit vector going straight up. Which would then force you to do another value, test a different value. Which is not what I want to do, I must admit. I'm just trying to get these written. In a test environment, you would probably write a page of tests just for one function. You would need at least 6 different variations of this test to satisfy the requirements, probably by whichever company you worked for. They would have a stipulation that each of these functions has to pass so many tests. I'm only doing one because I'm just shoving out the basic example of each test so people can get used to the idea. I mean, you can always go back and keep testing. There's nothing to stop you going back and breaking your own functions and keep testing. I mean, I've done a lot of that in the past as well. It's very, very interesting. It can get quite weird. What we're going to what are we going to return? We're going to return this because it's acting upon itself. Alright, so we'll start there. We'll start with getting rid of this rubbish. I'll put the equation in. And it's this, dotted, with the cross product. Now you know why I needed to get that tick on cross product. See, it's got a tick, I can use it. Excellent. I'll take that. And we are going to take axis dot mul. Do we have mul? Oh god, no. I haven't done mul. Great. Sine. I haven't done multiplication. That's not good. Dot. But I haven't done add either, have I? Add. Oh. I didn't know I got that. I might get that for free. Open brackets. This dot mul cos. I should have two closes, I think. Yep. And then the next line dot add. And I forgot my doobry. Open and add. Thank you. Axis. Oh god, can I do this one? Mul. It's this dot product with right, which is the axis. Dot mul. Oh, I love this equation. I absolutely adore it. And it's 1 minus cos. How many brackets have we got at the end there? 3. Well, that's 3 too many. That goes back to there. That goes back to there. Alright, I'm just trying to work out my brackets. No. It is, that's right. Oh my god. But I need to be able to multiply. Alright, so what I've done there is rotates on local x. Rotates on local z. If I remember rightly. Yeah, z. And then the last line rotates on the y. What do my notes say about this? Yeah, my notes are agreeing with me, but I'm really not happy with all of these brackets. Rotates on local Y. There is a problem with that equation, and I believe it's called gimbal locking. So I'm going to also put a note on here. May be prone to gimbal lock. That's when you point the camera straight up or straight down, it gets locked in position. Because of the local, it can't work out the locals properly, because they'll all be facing the same direction. So yeah, there's that. Sorry. More actions. So beware of gimbal locking. Thank you. I thought gimbal would have been a word, but never mind, it obviously isn't. We can't test it, because it won't. So I'm going to have to do another one. Damn it. Alright, so what do we need for multiplication? Float, I suppose. I haven't put anything back to float either, and it's accepted it all. Interesting. I'm a bit wary about this, because I'm used to this editor giving me lots and lots of information. Because you can see down the left-hand side, I mean, it tells you everything. And it's not coming up with anything here except red marks. I wonder. Okay. Whilst we're here, we'll do a couple of multiplications, I think. I didn't really want to do them here, but anyway. Public. Vec3. And it'll be mul. And Vec3 right. That's that one. No, don't do that. Do it that way. Then we've got public Vec3 mul open float right. I think that's the one it wants. Mul double. Okay. Oh, we haven't got the addition either. Clever me. Float. And float. Something else wrong here. Oh, silly me. One doesn't count. There we go. That's correct. And we also now need add. Thanks. Put add before multiply. Okay, we got everything off this one now. we have. Yeah. So, rotate. Has to come out. You can't leave it in now. Because it cannot be verified. And this test has to come out because it can't be used. Well, I don't know. We can just use it, leave it as a vec, one to come back to. Because now we have to do all of these. Great stuff. And they're all reds. So what do they return? New vec3s. That's a shame. I wanted to know if I got it right. And that's a semicolon. Okay. That's that lot done. Actually, am I going to be testing these? Should I be testing these? The answer is yes, you should test everything. Okay. They're literally worse than writing CSS. Oh dear, he's just been looking at VECTR. Oh wow. Oh wow. Even worse than CSS. Oh dear. Have you looked at Angular? Oh no, it's not like that, is it? There was something that I've passed by recently on my journeys around the internet. Anybody know of any good UIs? Either put it into chat or stick it down below in the comments for the video. Linksicat's looking for one. Oh right, you're already using Vue. Yes, that thing. I remember now. Thank you. Yes, indeed, you are. So, we need... Oops, done it wrong again. Add. We're doing a vec3 first, aren't we? Okay. Vector. Test method. Vec3. Add. Yeah, there's nothing that says you can't do more than one at a time. Yeah, I mean, doing UIs is one of my things, because I like taking the mickey out of Microsoft, as you know. And I always say, let's do the Microsoft button. And the buttons on Microsoft are rubbish. Everything's so flat. Look at it, it's all flat. This is native Microsoft, by the way, that I'm working within. It uses something or other. I can't remember what this one uses. Might be Vue that this one has. Look at what they've used to do this one on IntelliJ. Type into Google what IntelliJ, how was the UI constructed, and see what it comes up with. That's what I do. Yeah. So it's going to be vec3, and that's going to be mul. Is it vector first? I must admit, I do spend quite a lot of time browsing over the internet. I mean, I can't type for very long. I have about 2 hours worth of typing before my hands go. So I only get that amount per day. All the rest of the time I have to do research, which is why I became a researcher. Research and development. Swing. Haven't heard of swing. Or have I? It's triggering something, that swing. It might have crossed paths with it, but I haven't looked at it. So, vector. And the last test I need before we can do rotate. It's amazing what comes up in these. Whoops. Vector 3 mul float. Okay. Lovely. That's good. There should be a space there as well. Never mind. Alright. So I've got these four things I'm going to have to do. To add vectors. Okay, let's do some addition, shall we? Are we going to... Well, we're going to need two vectors, aren't we? We're going to have a left and a right. Yeah. So, vec3, left. I think I might be able to manage these ones. Mathematically, that is a new vec3. Anything you want in here. 2.0 f, comma, minus 3.3 f, comma, 4.2 f. That'll do. There you go, some handy random numbers. A random number generator is a good way of doing tests, but you've got to be careful. IIRC is what IntelliJ uses. How did I decide on Java for this project? Very easily. It's the best programming teaching language in the world. Look at all the help I get. You can't go wrong with Java. It's hard to get something wrong because you're always being told what to do. If you look at the screen, it's always telling you what to do. Especially on IntelliJ IDEA, which I'm using, it's very, very good at pointing out this could be done differently. That's what all the yellow marks on the right hand side are. This can be done differently. And it's good that way. I'd be good at making YouTube videos. iClinton97, I'll show you something. I've done so far on Amberskies videos. Let's have a look. All videos. Never going to fit on the page, is it? No. It just goes... Yeah, it doesn't show all the videos at all. You'd have to go through all the playlists. I mean, there's hundreds of them. As long as you say it says created playlists there, you'll see them all. I mean, there's tons. I've done well. I think I'm into the 200s now. So yeah, go and have a look at Amberskies. Nice little home. It's got a bit of entertainment on there if you want some. You know what I mean? Silly games being played. Right. So thank you for that, iClinton. That is a nice compliment. And I will accept your compliment with gratitude. some silly numbers now. 5.5 f, comma 10.25 f with a comma. Something went wrong there. 5.51, okay. Oops. Comma. I've got a D in there. What's that D doing there? And a 1.0 def. Let's see. I don't really want to go into doubles. Oh no. Right, let's add these two vectors together. See what we come up with. So it is left dot add. Right, hello Muppet. Muppet my cat's here. And yes, that's his real name. Well, actually no, it's not. It's my name for you, isn't it, love? Yeah, he likes the name of Muppet. He responds very well to it. Very tame. His real name, I can't say on video. I just realised. I'll type it in chat. Oh, I can't type it in chat either. I think it might break the rules. So anyway, we'll call him Muppet, because that's my nickname for him. So left add right. Are you coming? Oh, you're coming over here, Muppet. Thank you. We're at 2 hours, by the way, so we are on to the questions and answers time. HTML, CSS, and JS. I'm still wondering why you wanted to use those 3 parts, but it's fun. It's fun. I must admit, it gives me something to do on a Thursday. Come on, Muppet. Do you wanna like help out here? No, you don't. What's going on here with rotate? I thought I'd taken the rotate out. Oh no, I'll put it back in again because it doesn't matter. That's right. Copy. There we go. Never copy and paste. Ever. And that's an instruction. I'm not asking, I'm telling. Yeah, I mean, if you're doing client-side web stuff, there's an awful lot. There's an awful lot of code bases out there. I've really tried to stay away from those areas because I'm like a sponge. I would just learn too many languages. I'm already up to about 100. Yeah, there's a lot more support for JS, yeah. There is now. Didn't used to be. It always used to be PHP. That was the main. So change victim to left. That's all we need to do. Okay. What I'm going to do is to copy that lot. Am I? Yes. No. I'll copy you out to there. We'll just change it then. So left and right, and that becomes multiply. So that's okay. And all we need to do is put the numbers in. Right, so we've got add, and then we've got the floats to do afterwards. Okay, so let's do these. Addition is 7 minus 3.1. Oh, clever me. 2. So those are the answers to that one. All you do is add them up, straight down. Add, 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 add. So 7 minus 3.1 and add them together, 5.2. Yes, that's right. Multiplying the vectors is the same thing, really, isn't it? 2 5s are 10, so that's 11. Minus 3 times 0.2 is minus 6.6. Oh, no, minus 6.6. Yeah, 0. 6.6. Okay. So it's divide by 10 times by 2. That's right. And the last one is 4.2. There we go. So that's that done. Let's do the additions. I've got all the asserts in here, aren't they? Yeah. So we're going to need a left. Well, it's just a victim on this one, isn't it? Yeah, that'll do. Whatever it did. Victim. And we're going to have the victim version, aren't we? Which is this one. How are we doing in chat? Do you compile PHP? I thought that was just a browser that dealt with PHP running it. I don't know. It works on any system. It's a cross-platform language. Well, because it's in browsers, isn't it? And all browsers use it. It's like HTML. And PHP was the first embedded language. Yeah, that's a good point. Steve says, Steve7411, browsers don't know PHP. It's commonly used on servers. Correct. That's it. Thank you. Nice one. And what we're going to do here is take our victim and multiply by 10. I think that covers what the multiply should do. Yeah. So that will become 20. That will become minus 33. And the last one will become 42. My favourite number in the universe. There we go. Oh, that was add. Oh. Whoops. Just done the multiplication in the adds. So it's 12. Oh God, 6.7. And 14.2. There we go. Yeah, that's right. Take that lot. Make sure that says add. Before I do. Copy. And multiply. Now I can put them all in there. Now I can put silly numbers in here. Minus 33, wasn't it? And 42, yes. Fantastic. How are we looking over here? Yeah, Java doesn't support operator overloading. I know it's awkward because it means you start having to write loads and loads and loads of things that do well, not much, or aren't really productive, because like I'm having to write this twice. Yeah, like this, and test it all. So anyway, let's have a look at my testings and see that I've got my testings all set up. No, I haven't. Here we go. Oh, right, you can't do the rotation. Yeah. Right, that is a problem. Take the test out. Yeah. So I can't leave that test in, that's a shame. Hold on. Okay. Graphic design. It sounds interesting, Linksycat. Graphic design. The only graphics I've really played around with are simple sprites and 3D models. And I found I'm okay with 3D models, but I wasn't overly interested in it. It's not that I'm not any good at it, it's just I'm not really interested in it. Because to get good at it, you've got to practice and practice and practice. Where I prefer this nitty-gritty stuff. This floats my boat. What I'm doing now floats my boat. I like it. So how are we doing? 4 test fails. Okay. That is what I expected, isn't it? We can see them all. Can we take off? Show past. No, don't show past. Ah, that's better. Show failures. So that's the ones I wanted. Good. Now we can go and implement them. So this is the top one, isn't it? Okay. And this is going to be easy. Is it? Add is a new vec3. Yeah. Okay. Yeah, it should be alright. It's x plus right get x comma. What's wrong with get x now? What? Have I done it differently? Yeah, I've done it with lowercase. Really? Really? Never mind. This is going to get annoying. I'm going to have to change them all now, aren't I? No, I won't. Getters and setters. It's not my part of the program. Stuff them. I didn't write it. Y plus right dot get y comma. Can't this thing just go downwards? Yes, it can. Comma. And and z plus right dot get z. That adds that adds a vector to a vector. I should put that on a separate line, thank you. Yeah, that'll do. Yeah, rotate shouldn't mutate the input. I'm hoping it doesn't. All right, some good information here coming from Linksy Cat on chat about different things. That's great. Thank you, Linksy. That's good stuff. I'm going to steal you, and I'm going to take you to... No, I'm going to steal the whole thing, aren't I? Steal the block, that's why I put them in blocks. That's the whole idea of it. Right, for multiply... That's... So what have I just done now? Add vec right, add float right, multiply vec 3. Here it is. It's exactly the same, but with the multipliers there. Okay. And let's do this one now. Where are we here? So, what's this? Float x plus right y plus right and z plus right. There we go. That's that one. Take the block. Copy. Everything's okay. Down to the last one. Go. Run tests. Alrighty. That's always good to know. Alright, so they all are still hopefully failing. Yes, great. I thought I got it right, never mind. God damn it. Alrighty, let's start test at a time now. Vec3 add vector. Run test. I can already see a mistake. Expected true was false. Okay, back to normal. One at a time. 2 plus 5 is 7.5. Left dot add right returns a new vector. Do I have to put this equal to a result? I do, don't I? Okay, 3 result equals that. Result Okay. There you go, I got my test wrong. How to learn to program. Fantastic. Does this one return? It must return a value. Does add float really return a value? Yes, it does. It returns a new one. So yeah, this is result as well. Yeah, ain't that great? Test tick. Next one. Simple things like this can drive you mad, you know. Absolutely crazy. No, not really. That doesn't mutate the input correct. That's why they're written in that way. Okay, something's wrong here. And it was my typing again. Yay! Click, click. Can I go red to green? Green it goes, lovely. Vec 3, result. Did it? You see, that's the good thing about test-driven development. One side has to be wrong. It's usually the right-hand side, but sometimes it's just me being silly on the left-hand side. Let's run the test. Run the test. Ooh, failed. Right. Vec 3 mul failed. And why was that then? Two times 10 is 10. 2 times minus 3 is 6.6. Oh no. 10 times minus 3.3 is minus 33. Yeah, 42. What's not to like about that? I've done something wrong here. And there's the error. We are adding instead of multiplying. And that's why tests are written. To stop you from doing that. Run test. Oh, we get a green. Fantastic. So go back to the top now. Here. Everything that we've done is good. So we should be able to now do this one. Code. There we go. Where's our code here? Code. There we go. Let's run it and find out. Excellent. That's what I was expecting. Because I haven't put anything in. Oh, yes, I did. We rotated and it didn't work. Ooh. Oh. Alrighty. Same as before. Minimize your asserts. Alright, just keep rerunning it until we get the positives. Okay, so our x isn't going to 0. Alright, what I'm going to do then is I'm going to simplify everything in here. First of all, simplify whatever you've written. Get rid of all these. I'm sure there's a bracket out here somewhere. Alright, okay. Just changing everything over into floating point, so I've got nothing that's distracting me with this silly mathematics library, which I don't like. Prefer to write my own. Right, okay. Right. Yeah, it's returning the vec3, isn't it? Yeah, it's the way I've done the test, by the sounds of it. Yeah, I'll cheat. No, I won't. I'll do it properly. Result equals result. Yeah, it'll be the same thing, yeah. Hopefully. That I've done before, stupidly. Lovely. Let's just run this test again. See if I've made a difference. Okay, looks as though we're getting back to normality here. Put the other asserts back in. And rerun. Yeah, we've got it. Yeah, I'm happy with that rotate. But it's still prone to gimbals. Damn thing. I think I'm done. No, around 250. It looks as though I'm going for a marathon today. I've done add and float. So really, if you're thinking about it, you should really get these add tests. Copy. And make them into min. Is it into sub? Sub, isn't it? Subtraction. Try that again. Well, sub to me isn't subtraction. Do you have a 3x3 matrix class? No, I won't be doing one either. Probably. Unless you want me to. I'll do one if you want. Really nothing to do with 3D though. 3D game engine. Uses 4D matrices, I think. Yeah, Mat 4 is the next on my list. I skip Mat 3 every time. It's not as useful. Really isn't. Not when it comes to doing 3D graphics. I do have 3x3 matrix classes written, yes. I have 2. I think I've even got matrix 2 as well. And there's a 2.5 that I can also do. So there's 2, 2.5, 3 and 4D. And then there's, on the vectors, there's vec2, 3 and quaternions. You can have vec4s if you want, but I'm trying to keep away from them. They've spoilt the last maths library that I had. Spoilt the way I was thinking and the way I did things. Yeah. Yeah. Yeah, I can see what you're seeing there, Steve. Yeah, Steve's saying that you can use 4x4 for translations and stuff, but 3x3 rotations and the like, if performance is concerned. No, I'm not going to be using 3x3s for rotation because the gimbal lock is always there. You have to use 4x4 to get rid of that, and then you're into quaternions. So it's just it's all trade-offs. It's all trade-offs on how you do things. It's interesting though, I must admit. It's one of those things, really. Alright, so I've got 2 of those there. Alright, so that's a sub. Oh no, don't do this to me. There we go, SUB, that's all I wanted to do. And that's our subtracts, isn't it? But it's when you're doing a maths library, you do the bits you're going to use first, and then later on you add your bits. I think that's the best way of doing it. I'm doing more than I normally would because we've got like tests here that are working properly. I've got a test system working properly with a production area. So stuff it, I'll do it properly for once. For once in my whole life. I know. Right, these 2 here. Add. Where are they? There they go. So what I'm going to do is I'm just going to be very naughty and I'm going to copy. And that's going to then become sub. And that's going to become minus. Missed one. And that's going to become minus. We've written all the code already, so I'm not bothering going through the testing of it or anything like that. Why is that wrong? Oh, because I haven't done the sub. There we go. Right, so we've done the multiplication, we've done subs. So we've got add, normalize, rotate, add, subtract, added, multiplication. Oh. And then we're off into getters land. Okay, so take you to there, copy you, and just V you out. And I'm actually going to put in div. Never use it, but I'm going to put it in just for completeness. Should never divide. Never ever divide in computer programming. I know I have done so far in this series, but you shouldn't. Just multiply by decimal places or whatever. So those are that side. On this side I have to match. So I've got sub. That one there. Multiply, multiply. Copy. There we go. Yeah, I know this is not the way you're supposed to do it. I'm just trying to speed up because I'm running out of time for the day. I know my fingers are starting to give up already. So it's I'm racing against time here. Div. And div. Right. So I did subtraction and div there. Right. Div float. div float. Okay. Up and good. I don't know why it's... Oh, yeah, it'll give me green arrows because of that. Stupid thing. Run div float. It should be wrong. Give me a red. Yes, it gave me a red. Right. 2 divided by 10 is not 20. It's 0.2. Minus 3.3 divided by 10 is minus 0.33. And 42, 4.2 becomes 0.42. Is that correct? Yes. You could do a maths test on it, couldn't you? Okay. Dividing by another vector. And we haven't got it right, so let's see. Oh. Alright, I'm not having them values. How's about 10.10 F? Comma. I know. Yeah, we'll have that. Cheat. I know. 0.2 is the answer. Again, it's minus 3.3. Yep, that's okay. And that one is 0.42. Am I right? Run vector versus vector. Ooh. Nice. We got a tick. Excellent. So that's vector and float done. Alright, so we did that one, didn't we? Yeah. Done multiples. Subfloat. Run test. And subfloat is wrong. So let's check that I've typed it in right. I have. 2 minus 10 minus 8. Minus 3.3 minus 10 minus 6.7. Just got some minus, doesn't it? Hold on a minute. No, it doesn't. It's minus 13. How's about that then? I'll get it right in a minute. 0.3. That's better. 4.2 minus 10 is minus 5.8. Am I correct? Yay, we are correct. Okay, got the vector here. Excellent. It doesn't work. Make sure everything's correct. Thank you. 2 minus 5.5. Why did I try this one? It's minus 3.5. I'm not certain, but I'll put that in anyway. Yeah, Steve's spotted a good error there. Well done. Good on you, mate. Just call them out. If you see me making mistakes, always call them out on chat. Don't be afraid. There's no comeback from me. It's always thank you for the help. I need all the help I can get. Minus 0.2. Alright, that's 0.5 there. 4.2 minus 1 is 3. Is that correct? Yes, it is. Right, have I missed anything? Probably is the answer. So what we do, if we go right back up to the top, and this very first button here, run tests. Test results. Oh, nice. That's everything. Wow. So was that everything there? What happens if I push that one there? Okay. All right. I'm not showing them, that's why. There you go. All tests passed. Something to look at is an 8 millisecond. It's not really worth it until you're running more tests or bigger tests. You need more stuff in there to spot it. These milliseconds aren't worth it because I'm not testing properly. Each one of these should be a page of writing in its own right. Literally, it should be a lot more than that I'm doing. You should be going with positives, minuses, awkward numbers like 0.1, 0.7, and I think 0.79 is another one, and 0.9 is another one. Go with the awkward numbers. Go with things that can't be stored in binary. 0.1 can't be stored in binary. So you're looking for your maths, not just to break the rules over here, but to break the rules of epsilon that you've set at the top for your floating 4 decimal places. Okay, so I like that. I think that's cute. It's nice. It's a nice little bit that we can add. I like it. But we now have enough here for a maths library. More than enough. We have absolutely everything. It's like a wow. So I'm really happy with that. I now need to fill in, yeah, because I lost them like an idiot. I'll do that off screen though. That's my fault. I didn't put a marker on that disc saying mine. Didn't put my name on the disc. Things happen. But what am I up to next? What are we on Saturday? I am up to, where's my sheet? Where am I in my notes? Okay, what we got? Monday, Wednesday, Friday, 2 p.m. in the afternoon, we have Amberskies, the C++ Gaming Club. During the time that we're on air for 2 to 3 hours, it's Mission Impossible, let's program an MMO, and I do stupid things. I write silly functions and see if they work. Some do. It's quite surprising. Thursdays is Blade's World, behind the scenes look into the research and development, which I do. Next week I am looking into Node.js, as suggested by Linksycat. Why not? So I'll be doing that. Trying to hook it up with other things. I'm not going to try and see how many different things I can hook Node.js up to in different ways. Saturdays is today, Learn to Program, where I go through the details, not just the intricacies, but the details of how to program. Not necessarily the code. I'm not hell-bent on teaching you the code. I'm not teaching you how to program Java. I'm here and hell-bent to teach you how to program. And there's a big difference. So don't expect to learn Java, although you probably will in the process. Yeah, I mean, by the end of this, I would like you to be able to look at any language and say, yes, I can program in that language if I take it slowly to begin with, and won't be afraid to use any language at all, because you'll understand that you can't make a mess of things, you can't really get things wrong as long as you do things properly. And if you follow the way I'm doing things and use tests, you don't have to test everything really, but really I think you should, personally. But that's your choice, what your boundaries are. People have their own boundaries. And again, I will always write down the page, now you know why. Because you can do that. So now I've got all my tests next to my code. And I can look at all of these. Well, even getters and setters have already been pulled up by the system. I mean, I've gone overboard slightly in this area. What's the green one for? Access can be... yeah, okay. It's because it hasn't been properly accessed by the looks of that. Shouldn't have a green one, really, I didn't think. Did I not do the divs? Surely I did the divs. Make sure I did it right. Yeah, we got it right. That's better. No. It's access can be packaged private. Why has it flagged that one for that? That's weird. How have I written it? Oh, of course it can, yeah. Oh, wow. Fantastic. Well done to IntelliSense. It spotted something that I didn't. So that's why I always try and work down the page. It's so that when you come to actually play with it, you can do. And the screen that I use is like 4 of these screens. So yeah, in one, it's 4K. This is only 1080 of it, 1080p of it. So you're in the bottom right hand corner at the moment. I've got another 3/4 of screens here. I'd like to thank you all for popping by. I'd like to thank all the comments and everything. That's been brilliant. The chat's been good today. Hats off to all of you in the chat. So I will sign off, I think. Have we got music? I usually sign off with music when I'm on Windows, don't I? Here we go. So, this is me from Amberskies. We're in the weekend. I'm coding, and I've got more code to do, and I'm going to have fun doing it. So, I'd like you all to take care. And thanks for stopping by, and the chat, been brilliant. I want you all to carry on programming, and I want you all to learn as much as you can, and never stop learning, even at my age, because you're always going to have fun. Take care and have fun, peeps.